Hello everyone, and welcome to the series lecture. Series are going to be the first main data type that we'll be working with pandas, and then we'll build off of series to work with data frames in the next lecture. Let's go ahead and get started by jumping to the Jupyter Notebook. Alright, here I am at the Jupyter Notebook. A series is very similar to a NumPy array. In fact, it's actually built on top of a NumPy array object, but what differentiates the NumPy array from a pandas series is that a series can have access labels, meaning it can be indexed by a label. Let's go ahead and say import numpy as np, and then I will import pandas as pd. And what we're going to start off with is creating various series from various object types. I'm going to make 4 Python objects. I'll create a list called labels, and this will just be 3 letters or 3 strings in a list, A, B, and C. Then I'm going to go ahead and make a list called my_data, and I will say it's 10, 20, 30. Then I will create an object called ARR, and this will be a NumPy array, and I'll just pass in my data. So one is a Python list, and another is a NumPy array. And then finally, as a dictionary, I will pass in A as a key, 10 as a value, B as a key, 20 as a value, and then C as a key, and 30 as a value. And that means I have 4 separate Python objects. I have labels, my list, and then I have my data, I have my array, and then finally, I have my dictionary. Okay, let's show you how you can create a series and what it actually looks like. You can say pd.series, and note here, I'm not actually saving the series to any variable name. I'm just using pd.series. But if you do Shift Tab here, you'll notice PD series takes a wide variety of parameters. We're just going to focus right now on the data and the index, which are the most important ones. First off, we'll just pass in data, and we'll set that equal to my_data. We'll just pass in that list. And note here, I get my series back. And it looks a lot like a NumPy array, except here it's very distinguished that we have an index 0, 1, 2, and then the actual data 10, 20, 30. And the key to a pandas series is that you can actually specify what you want that index to be. For instance, I'm going to go ahead and say pd.series. I will pass in data equal to my data, and then I will specify that the index is equal to labels. And remember, that's A, B, and C up here. So when I run this, now I have a labeled index series. So I have A as the label, or the index, and then 10 as the actual data point for that index. So unlike a NumPy array, I actually have index that are labeled, meaning I can call these data points using this labeled index. And just as a quick note, since data and index are actually in order as far as placing them in as parameters, you don't have to say data equals or index equals. You could just say my data and then labels as such, and you would also get out a series in the same manner. So you don't need to constantly specify data equals or index equals, as long as you put them in the correct order. Alright, let's go ahead and show you a couple more ways to create a series before we actually start working with data in a series. Another quick way to create a series is by saying pd.series, and you can pass in a NumPy array. And this is going to work exactly the same as a Python list. So here I pass in the NumPy array, and it worked the same way. And just like the list, I could have also passed in labels along with this NumPy array. So essentially a NumPy array is going to work the same thing as a Python list as far as passing it into a series. And then finally, what's really cool is you can say pd series and just pass in a dictionary. And what pandas is going to do is it's going to automatically take the keys of that dictionary. Let me just go ahead and show it here again. Take the keys of that dictionary, set it as an index, and then set the value of that key to the corresponding data point. So that's a nice fast way to quickly create a series. Alright, something to note here, and another thing that differentiates a NumPy array from a pandas series, is that a pandas series can actually hold a variety of object types. Right now we've shown a pandas series, pd.series, holding just numbers. So for instance, I've shown it holding just an array of numbers, but it could have also held as the data labels itself, which remember is labels. If I go ahead and run this here, is just strings. So a series can actually hold pretty much almost any type of data object with Python as its data point. So it can be strings, and even more interesting than that, we could say data equals, and you could have actually passed in built-in functions. So I could say something like sum, print, len, and it's actually holding references to these built-in functions as data points in this pandas series. And that's not something you can do with a NumPy array. Now, you'll probably never actually use this as far as hosting functions or references to functions in a pandas series, but this is just to demonstrate the flexibility of a pandas series as far as holding different object types. All right, let's go ahead and move on to actually using an index. The key to using a series is understanding its index, and pandas makes use of these index names or numbers by allowing for very fast lookups of information, and it works just like a hash table or a dictionary. Let's go ahead and see some examples of how we can grab information from a series. In order to do this, I'm going to create two series. I'm going to make one called ser1 and say pd.series. I'm going to pass in some data. We'll go ahead and say 1, 2, 3, 4, so just a list for my data. And then for the index, I'm going to go ahead and put in some country names, such as USA. We'll put in Germany. We'll put in USSR. And then Japan. So these are kind of like World War II country name references with some values. So I'm going to check out series 1, ser1. And here I have my series. Notice now I have index labels, and 1, 2, 3, 4 are my data points. And note it'll say dtype integer 64 since my actual data points are all integers. Then I'm going to make series 2 in a very similar fashion. I'll say pd.series 1, 2, let's say 5, 4. And then for the index, I'll go ahead and say USA, Germany, and I'm going to on purpose change one of these. We'll say Italy as another World War II country, and then we'll say Japan. And then if I check out series 2, I get 1, 2, 5, 4. So Italy's a little different here and it has a different data point. Now, if I actually want to grab information out of the series, it's going to work very similar to grabbing information out of a Python dictionary. You type in the series, and then as a string, you can go ahead and type in the actual index label, USA. Now, keep in mind, I'm typing this as a string because I know that the index is a string. If I'm working with a series, such as up here, that has 0, 1, or 2, you would just pass in an integer. It depends on what data type is your actual index. All right. Usually your index is going to be hopefully either a number or a string, so you can either pass in ser1 and then the string, or ser1 and whatever your integer index is. So for example, if I quickly create another series, such as ser3, we'll go ahead and say pd.series, and we'll just pass in the data as labels. If I check ser3, no, I have A, B, C as my data points. dtype is an object, which kind of refers to the fact that it's a string, and I can grab stuff out of this by the integer index, which is kind of typically how you would do this for a NumPy array. And then there's the string A returned to me. So you just pass in the actual index label, and it'll return the data that corresponds to that index label. As far as very basic operations to do with a series, they're usually done based off the index, meaning if I were to say something like ser1, and then we have ser2, and let's say I try to add these. So I say ser1 plus ser2. What's going to happen is it's going to try to match up the operation based off the index. So it's going to say USA is 1 here, and USA is 1 here. So it'll add them up and say, as a result, USA will be equal to 2. Where it cannot find the match, such as Italy, it will put a null. And then USSR is also not in both of them, so it's going to also put a nan object there. Let's go ahead and see what happens when we run this. And there we see the results. So USA was 2.0, Japan was 8.0, Germany was 4.0, and then where it didn't find the match, it went ahead and put in a null value. Something to note here is that when you're performing operations with a pandas series, and really pretty much almost any NumPy or pandas based object, your integers are going to be converted into floats. And that's so you don't accidentally lose information based off of some weird division. And that has to do more with Python 2 and the fact that true division versus classic division is actually differentiated in that older version. If you're using Python 3, you basically don't have to worry about this, but you just have to keep in mind that pandas and NumPy will always convert stuff to float in order to retain all the information possible. Okay, we'll go ahead and stop here for now and move on to data frames, which is going to expand a lot more on the concept of series. In order to fully understand data frames, you just need to know the basics of series, which is just that they have a labeled index and then a data point. Really, throughout this course, we're not going to be working too much with series. We're going to be working a lot more with data frames, which is the true workhorse of pandas. Let's go ahead and jump to the next lecture where we'll talk in a lot more detail about pandas data frames. Thanks everyone, and I'll see you at the next lecture.